gets processed. So, okay.
Good.
Okay.
Hello, everybody. This is where you say hello.
Hi.
Hi. Thank you. So, before we start, a couple of things. I gave this talk yesterday, and I wanted to cover a bunch of things, and I had like half an hour, and I actually only covered a couple of things. So we're going to go through as much of this as I can, and you can ask questions at the end, or maybe I can just, if you're really, really interested, I'll give you a private talk. The second thing is I woke up this morning feeling like I'm dying and my throat is killing me. So please be really gentle with me and be nice, because this is also my first time speaking here. Okay, so me. I'm Daniel Houston. I moved to Latvia, like, as you can tell, I'm not from around these parts. I moved from Latvia from the UK about a month ago, almost exactly now. I now work as a technical team lead in Accenture Riga. But before that, and the topic of mostly what we're going to talk about today, I worked in IBM in Cambridge, where I was a member of the founding DevOps team there. Which is to say, I should mention some stuff. The systems we're going to talk about today, they belong to IBM. I can't show you code from stuff that we set up there because it doesn't belong to me, it now belongs to IBM. I don't any longer represent IBM, especially because we're recording this, and it's good that I mentioned this kind of stuff. So unfortunately I'd like to show you like the inner details, but I can't. So we'll just go over the concepts. So, as I said, was a member of one of the founding members of the DevOps team. This is kind of like an overview of the kind of stuff we were supporting. There were 4 developers, one of them including me. We had one dedicated QA person, one person running the in-house like bespoke artifact store, and a manager who didn't really do a lot of work. So the systems that we supported here was a suite of Jenkins Service, and including the configuration for them, their plugins and stuff, and all of the slaves that ran from them. Docker infrastructure, which included just about everything for anybody who uses Docker. It was the registry, it was the creation of the images, the storing of the images, the hosts on which the images run, and obviously managing containers. This represents our configuration as code stuff. We deployed to our containers and all of our environments I'll get to in a moment, using Ansible and some bash, and depending on Windows, because we were a Windows shop, as you saw from my logo in the beginning, I'm a Windows fan. So we used Ansible and like operating system magic to deploy. And we supported all of the hardware environments that were built on and were used for build, test, and development. That includes VMs that were like long running, static machines, because we're old school and some people still have like actual build machines. Stuff that was provisioned in the cloud, including OpenStack and Docker, and some interesting stuff that was not headless, not typical servers. It was like graphic-enabled GPU machines for testing GPU throughput on like performance levels for big data sets and stuff. But we won't be talking about that. And also the in-house artifact store that we built was kind of like Maven-esque, but I can't talk too much about that because that belongs to IBM. Okay, so what did I say here? Oh yeah, so the first thing that we managed to set was the Jenkins Service. This was for, as you can see down the bottom here, right? These are representative of the products that were supported by the DevOps team. Now, I should clarify, this was a centralized DevOps team that ran like kind of supporting all of these products, including the sites in Cambridge, in America, Dublin, stuff like that. That isn't how everybody thinks DevOps should be done in particular. Some people believe that it should be more distributed. I'm not here to talk about how DevOps should be, how it shouldn't be, talk about what I've done, how it works. So, yep, multiple Jenkins masters, maybe like 5 or so of them, supporting 9 different projects. Each of these come together to make maybe like 5 or 6 enterprise level products. So we're talking big scale here, like multi-million. Now, for having 4 people or 4 main developers supporting that kind of stuff, you kind of need to have some sort of configuration as code way of having a deterministic environment to run all of the builds, right? Like, because you can't manage those jobs manually. You can't have people just kind of logging in and updating stuff through the Jenkins UI, because that sucks. So, who here is familiar with Jenkins as it is? Show of hands. Less than I thought. Okay, so on disk, when you make a Jenkins job, it turns up as a config XML file. Right, so like the whole job is self-contained. I'm bringing one up now. Looks like this. Right? A lot of shit going on here. It's XML markup. You could conceivably take this file and you could just like stick it in source control and be done, right? You could just say, okay, we'll just check in each of our. Sorry. Sorry. There's somebody noticed it. But you weren't meant to mention it. People were going to pick that up on themselves. So you made me lose my point. You could check this into source control. You could just have developers update these things on a regular basis through source control and then push the contents of that to the Jenkins server, reload from disk, the configuration options, and you'd be done. The problem with that is it's not programmatic any more than just managing a bunch of files on disk, right? So each of these needs to be manually maintained. You need to understand the syntax of what goes where. Syntactically, excuse me. Yeah. Syntactically, it's not possible, right? Like it's just an awful lot of effort to learn that you need to use the Hudson.model.string parameter definition to define the project name. So there are other solutions, right? What you can do is, if I bring this back across, you can use the Jenkins files, which is what I believe the previous presenter talked a little bit about. Oh shit, there you go. You can use the Jenkins files. For anybody who's not familiar with Jenkins files, they are a somewhat Groovy-esque way of defining Jenkins jobs. So we're kind of getting this one level of abstraction away from the config XML. If I can just load one of these up, I'll give you a quick example. There we go. Is that legible? Hold on, we'll go into the fancy view. Okay. Sick. So it's a little better, right? We can define where we want stuff to run, kind of almost in English, the parameters for it. But it's not perfect. We're in a step in the right direction, but we still have like syntactical issues to deal with here from a managing these on scale perspective. You need to know that in order to follow the build, you can't see it go off screen here, but this is the part of the entry you need to follow the build, so they only run once an hour, for example. You need to know that you need to implement class, job, property, implementer, follow, can, is this. It's better, we're getting better, it's just not perfect. So, kind of in parallel to the Jenkins files, there's this groovy Jenkins Dsl plugin. Is anybody familiar with this who's used Jenkins before? Awesome. Hopefully you'll find the next thing, which is a big primary part of what we're talking about, kind of interesting. So, that plugin makes life a little bit easier. Go away, please. Oh, it's because it's in presentation. So, yeah, the Groovy plugin kind of is an equivalent. It's not the same as the Jenkins file, but what it is kind of defining it in pure Groovy code. You interact with Groovy or Java objects. You add or call method calls that pass through like parameter options, or like add where this slave can, or which node this job can run on, or add a parameter to the job that's running. So it's more programmatic, but it suffers from the same syntactical issues. So in order to use that, you need to know Groovy, funnily enough, and not everybody in your organization is going to be able to do that. And we'll come to a bit more about how you can spread that later, but the way around that, and the solution that we came up with in this team, was to abstract that one level up. So leveraging the Groovy DSL plugin, we built our own DSL, sitting on top of it. Which looks like this. this is an example job of kind of like a module Jenkins Dsl language that we built within IBM. So you can see that it essentially just, if those who are familiar with Groovy, shoot.
Is it open source?
It's not, because it belongs to IBM. This is actually abstracted away, this isn't the particulars. But maybe you can walk away with the knowledge you gained here and build something yourself. Or talk to me later. So, you can see here that, for those familiar with Groovy or Java, this is essentially just a map. Right? And inside the map you've got a bunch of keys that define the areas that the job is going to work in, or configuration areas for the job. And then using the values, you just define the values for the keys. Name, the description of the job. We'll come to the modules in a second. The parameters, the URL that the Git's repository is going to pull from, credentials, etc., and targets. Now, let's go back here. So, one of the key parts here is we kind of split the job definition down into a bunch of modules. With what's the word? Sensible defaults, I suppose. So, if you wanted to define a job that interacted with Git, you would include the Git module. And in doing so, when we pre-process this file, you're going to fetch down the Git module source code and then apply all of its default behaviors to the job object in the Groovy plugin. Now, in this case, you can see we're actually editing stuff for the Groovy modules. But things like the Java module, in order to implement that from a Groovy Dsl API perspective, you have to do an awful lot more than define the Groovy doctor. So essentially, what we're doing here is abstracting away the need to understand the Groovy Jenkins Dsl plugin in order to provide the simplicity of defining jobs in like a string value kind of way. So, there we go. So this is how the project kind of lays out, right? So there's each of the projects would contain a jobs definition and a views definition. By the way, Jenkins files support, or Jenkins file definitions for jobs still don't support views, so this is, categorically better than the Jenkins files implementation for the time being. Otherwise, you've got all of the modules that you want to be able to include still in the core folder under modules, and when we pre-process each of the job definitions, we just iterate through here and pull in the respective ones that are in the definition. One of the other benefits that we've got here over the Jenkins file approach, for those who have used Jenkins files or any other Jenkins programmatic way of defining jobs, is that you've got no way of testing them without having a running Jenkins instance. Right? That's a pain in the arse. So we have a local way of invoking the Jenkins Dsl plugin, because that's just a Java library, right? A Java library that provides the means of creating config XMLs. So we pre-process the job definitions, create the job objects, spit out the config XML to local disk, get the respective job if it exists on the Jenkins server that you're pointing the DSL job at, because of course you know where you want to build it and you know the name of the job that you want to keep in step, so you can pull down the config XML. And then we just see if they're syntactically correct. We can do comparisons, you can do diffs against things, you can see what it is that's changed amongst the functionality of the jobs. And we can also, one of the benefits of having this all written in Groovy is that while the definitions for the jobs can remain simplistic, the processing or the pre-processing doesn't necessarily have to be. So what you can do is any degree of validation on the fields that are entered in the job definitions that you want to, including how they are represented in the XML. So like you can check that the stuff that you're creating looks how you want it to be locally, and you can check that it's syntactically correct locally without having to have a Jenkins instance. It saves a bunch of time, because we all know, like, even when you have CM and your turnarounds are really quick, like if you've made changes to a build, you push it to source control, it gets polled, it builds the new job. Oh, it broke because I missed a comma or something somewhere. You don't have to do that. That ties up executors on your Jenkins instance, and it just slows throughput down. It's just useless, almost unit test level stuff that we just don't have a solution for in existing CM solutions for Jenkins. So yeah, we have means of testing it. This is, if it wasn't clear, this is the kind of pipeline. You define your jobs in kind of plain text. It goes through the through Jenkins jobs, these even on production or locally. It goes through the Jenkins Groovy DSL plugin, which produces the equivalent Jenkins Groovy DSL code. That code is then parsed to produce the config XMLs that go on disk. The benefits of using this kind of like abstracted model. It's easy to write, and we'll come to why that's important later. I mean, the obvious idea is that it's quicker, right? You can just, you don't have to learn, your developers don't have to learn how the APIs work for them to be able to leverage the solutions that you're putting together. It's also, like, it's important that it's more extensible, right? We can define modules of behavior and then share them across business areas. So if somebody wants to use Git, they write a module that uses Git. And if somebody else wants to use it, they can reuse the existing module, or they can fork it, and then they can store that in source control. It's like a, it saves from, well, I already have it written here, right? But it saves you from having to repeat yourself when it comes to like the job definitions. Because even when you use the Groovy DSL plugin, people are managing jobs on a per job basis, as opposed to looking at it from an overview. By having a centralized resource that allows a platform for managing all the jobs, you kind of take that responsibility away. It's also Groovy, which is kind of like, is useful in so much as that if you know it, you can write whatever you want to pre-process your definitions before they get pre-processed into Groovy code. So if you're familiar with Groovy, you could, for example, iterate through all of your definitions, because it's just a map. Iterate through them, do some pre-processing yourself, so set the releasable versions to a certain number. Or check that the naming convention is to a particular pattern that you need to use for your coding conventions. Like, if you know Groovy, you can build on top of this platform. It's testable, we already spoke about that. You can't test existing solutions for this. Or at least as far as I'm aware, there's no way of doing it without an existing Jenkins instance running. And that we support views, which other things don't. It is another abstraction, right? In order to understand how the definition files are being pre-processed, you would need to go into the Groovy modules code, and that's available because you're pulling it down. Like, you can go into the, as I showed before, you can go into the core modules folder and look at what each of these are doing, and it was encouraged, right? But it is another level of abstraction, and it is yet another convention, right? In order to use this, you need to understand how this works, but realistically, this isn't a drawback, because knowing how this works is a damn sight simpler than knowing how the existing plugin works, or the Jenkins file stuff works. What else do I want to say about the Jenkins solution? That's most of it, right? Yeah, we'll come back to that. Okay, so the other part of the system, which this is probably the only one we'll talk about today, is we manage the whole Docker suite of repository building, test, and hosting for the development, test, and build environments. Is everybody relatively familiar with containerization as a concept? Good, thank you. I don't know how to explain how that works. So, great thing about containers is that they're reproducible and they're nice and cornered off. You get a nice deterministic environment for you to do things in. Right? And from a slave perspective, from Jenkins, that's really useful because you know what's on your slave when you run it. You don't have dependency issues anymore. You can define that stuff. So you know that every time you invoke a Jenkins slave, it's going to be like this. It's not dirty from the previous run, for example. Which is great, except if you're running integration tests or anything that runs on the CI system, you don't want to kind of run your tests in the same place that your Jenkins slave agent is, because then it's no longer representative of your test environment, right? Because if your product test environment is, say, using one version of Java, and your slave agent requires you to use another version of Java, for example, I don't know, you had to use the IBM JVM for some reason in your slaves, even though it's terrible, and then you had to use, your customers wanted to support the Oracle JVM, having two JVMs in within the same container, it is impossible, but it just is an added layer of complexity, and it's crossing the boundaries of responsibility almost. where you're testing stuff doesn't care about the build environment, and the build environment shouldn't care about what's being tested on it. So what was the solution there? As anybody might have guessed by the logo, we ran Docker containers within Docker containers here. So rather than running it all in one slave container, we had a slave definition that defined the access to like the SCM repositories, the artifact repositories, and user management stuff like this, all the slave agent for the Jenkins configuration. We had that in one container, and then when that had spun up, connected to Jenkins and received the job to run, it would then use the information from the job it's running to spin up another container within itself initially. I'd also installed Docker in itself, obviously. So
are you actually using Docker in Docker, or are you just mounting the socket?
I'm glad you asked, because we initially did Docker in Docker. And we did that for, this was like pre 1.0. We did this for like 6 months. And it worked-ish most of the time. Like, it was fine. What we ended up hitting was like really weird network address translation issues. Like, especially when you were trying to communicate out of it, when you were trying to hit like, say, we were trying to pull stuff from our artifact store. So,
Git repository.
yeah, sure. But our particular issue was we were trying to pull stuff down from the artifact store, and we'd get like halfway through the transaction, and it would just say, no root to host anymore. And I'm like, oh, okay. This wasn't like an intermittent issue. We spent ages trying to fix it. But we weren't able to in the end. So what we did actually inevitably end up doing was manning the socket through. So we used to have this concept of Docker parent and sibling, parent and child, sorry. But what that eventually came up to being was a sibling containers. So one container spins up the slave environment, and then by mounting the socket through to the host, which is the same socket that spun up the slave container, we spin up a test environment. So they sit alongside each other on a host. So thank you for asking, because it gave me an opportunity to explain that. Why that's important, rather than just like, oh, look at the cool stuff we did. That's important because you get a nice separation between your build environment and your test environment. You can trust the test results that come out of your test container because they are representative of the customer's environment, or at least representative of the definition that you made of the customer's environment. And it's these kind of barriers between the build infrastructure and what the build infrastructure is being used for that really help, we'll get to this later, but really help you kind of scale as a DevOps team, because you can focus on what it is you're responsible for. You can focus on shoring up the stuff that is the infrastructure that's cared about, and spend less time fixing issues that are down to definitions done by the developers who are using it. One benefit for centralized DevOps teams is you get to focus on the infrastructure. So, for one reason or another that I can't tell you, we had to run everything on one stack, on one machine. So customers basically wanted to be able to run the whole stack on one box. So as much as we wanted to leverage like microservices, we weren't able to. It's basically the same problem as the Jenkins jobs, right? Because what that means is to test different environments, you need to manage different loads of Jenkins files. If this is one Jenkins file that represents one customer environment, you need to manage one of these for each of the customer environment. So how do you solve that? Well, you solve it in exactly the same way we solved the issue with, is it that boring? Sorry. We solved that in exactly the same way we solved the jobs issue, right? You just modularize it. Break it down into a series of functionalities. So, I don't know, one that installs the users, this installs DB2, and then does apt-get or something like that. That's what I've got here. It doesn't matter what it does. You break it down into different pieces of functionality so that when you're trying to build the images up, you can just, developers themselves can pick and choose the functionality they want. You don't have to manage those, or developers don't have to manage those. Because what we're getting at here is trying to simplify interacting with your infrastructure. Because you've heard the trope, right? People say about DevOps, it takes loads of effort. Like, I haven't got the time to manage all of that stuff. That's because it's just too complicated. It's too much burden of knowledge to be able to implement these things. So what we want to do is make that simpler. I want to do a quick check. Right? I mentioned that managing each of these is effort, and you're going to me, yeah, but the testing team can probably manage all of those. It's not too much. I mean, what do we pay them for if not to do that? That is from what I remember, representative of the different customer environments that we had to support. Who wants to hazard a guess how many unique combinations that makes? Not you, Edgars, because you know. And just shot in the dark, how many unique customer environments do you think we have to support?
Do we calculate permutations here?
Yes.
Okay.
1,500 around.
Close. 1,728. So, and this isn't that unusual, right? 6 databases, maybe 3 versions of DB2, 1 version of latest Oracle, latest SQL, and something else. That's not particularly unusual, especially locales, which just ramp it up. If you want to be L&M, then, or if you want to be relevant on an international scale, you've got to test in each of these areas, and people go, oh, it's not worth it because it's always the same. It's not. We had something with Turkish eyes, which completely broke the system. For some reason, message queue couldn't handle Turkish eyes. So yeah, it's worth testing stuff locally. But yeah, it's 1,700 combinations. Right? No one wants to manage 1,700 combinations of things. By breaking it down into different modules, what you can do and what we did was when you want to run a test, you define the functionality that you want or you need in order to run your tests. And then at runtime you can pull the fragments in, build the resulting Docker image from the fragments, and then push that to a repository, and then the build pulls that down and runs it. Right? You've got it just in time. It saves loads of time, and this is the kind of mentality that you need to take forward to be able to do these things at scale. Right? You need to break things down into chunks that are manageable. Chunks that are manageable just in time, as opposed to managing loads of big things at once. It's not very clear, but you should get it from the exam. So I've been talking for like half an hour-ish now. So I'm going to skip over a bunch of stuff here. This represents our configuration as code stuff, right? It's pretty cookie cutter in comparison to the last two things. Using Ansible to drive the configuration of the Jenkins slaves, and the configuration, there should be an arrow here, configuration of the static slaves or any of the development environments. Because each of these have the ability to pull down one of these Docker files, for example, and run, well, anything that they want to do, a customer environment in their local environment, to run their unit tests, for example. So likewise, they need to be able to run the configuration as code stuff to be able to bring themselves to the same customer environment. So we're not going to talk about that, it's pretty boring. I kind of spoke about that, equally not very boring. I would love to spend ages talking about our bespoke, IBM's bespoke artifact store system, but again, we don't have time, so the stuff that I actually want to make clear here is people think of DevOps as like, okay, so I'm going to put a question out. What do people think DevOps is? Like, what's the goal? And no one's going to get it right.
It depends on which definition you're reading.
Huh?
You know, it
Yes.
depends on the source you're
What's
reading
yours?
from. Mine, I would say it's a hybrid between a developer and infrastructure guys.
Yeah.
Because usually.
But what are they trying to achieve?
Smooth
Stuff
pipeline.
running.
No,
Stuff running? What?
stuff running is, let's say, the getting a product from developer to the client.
Getting closer. Who whispered efficiency? Because that's kind of true. Again, it's the same kind of idea, right? Like, it's about. Okay, I'm going to give you my personal definition of it, and you can all disagree. It's about reducing the difficulty for developers, and developers don't necessarily mean run-of-the-mill Java web application developers, to doing their job. Right? At the end of the day, you need to remove all of the barriers that stop people from writing code, that stop them from doing what they're essentially paid to do. And the reason I bring this up is because DevOps can help areas of your business that usually are overlooked, right? You might have saw in the synopsis for this talk, we talked about how we use DevOps in documentation to reduce their build times to their release times from like weeks down to hours, which is crazy when you think of the productivity save. But it's not just about the time to market, it's also about how much time people are spending messing around with that shit in contrast to actually writing documentation. Right? Has anybody ever worked with research coders before? No? Anybody worked with people like R&D? Okay, so they write terrible code. They write like the worst code. They're really smart, and I'm sure that the code is like really important, but it's like the messiest stuff. They don't give a shit about CI or testing even, or anything like that. But if you expose APIs in a modular way, like we did with the Jenkins jobs, and like you do with the Docker containers, where you can just define areas of functionality, and they can be responsible and quite easily manage those kind of small chunks of work. It's much easier to integrate them, right? And documentation is a great example. Like, I want to show you something. So this is an example of how documentation. Yeah, awesome. So this is an example of how documentation people with IBM Cambridge would define some of their jobs. Are you familiar with this? Is the DSL we showed earlier. So can you read this? Is that legible to people? Yeah?
Got it?
Good enough. You can see here there's basically two entries. You'd never guess what this does. Add translated doc job. Right? What that actually does under the covers is pulls down a bunch of source from this defined stream, which is all of data source files, packages it, sends it off to an offsite thing, offsite process that processes it into XHTML. That comes back. We do a lot of validity checks on the XHTML to make sure that the translated copies of the source match the untranslated copies of the source. Then it runs SPF locale to run HTML help compiler in a various of different locales, each for one of the translated locales, to produce CHMs. Then it pushes that to the artifact store, right? You want to write the Jenkins configuration file for that as a documenter. You know, it's the same action for every single project. Like, can we go back to the thing? Like, if we go back to, what's this? Yeah. So if we go back to the supported projects, right? Documentation have to support all of these, or they have to support, say, 5 or 6 enterprise level products or whatever.
But this is just reusability.
It is, but it's abstraction and reusability, and this is the point that I'm trying to make here, is that it's not something that people are leveraging. Right? It's the part of DevOps that allows you to reach areas of the business that are currently untouched, and because documentation ID writers, they can handle writing that stuff. They can handle writing the definitions as per the DSL that I showed, like a couple of lines. They understand where the source is coming from and what the downstream job is. They don't understand how to invoke all of the process that I mentioned before. So rather than them having to come to you as a DevOps team and saying, can you do this for us because I don't understand it, and rather than them having to learn how it works so they can support it, we've got this nice halfway house where it's just supported by the platform and it's extensible and you write it once, and then if you need extra behavior, you just add on top of that part of the platform. And the important part about this is, and I brought up the fact that it was for developers for a reason, right? This allows you to scale, right? These systems are all supported by for developers only because we have reusability, as you say, and abstraction away to the point where we can let the developers define the behavior of the platform. So we don't have to do that for them. They no longer have to come to us and say, I need a job that does that, can you set that up for me? Or my test environment is messing around with the version of the build agent you installed, can you sort that out for me? But we don't get support tickets from that perspective, which allows us to spend more time on developing more DevOps features. Right? 90% of my time was spent improving the existing architecture, and 10% of it was spent fighting bugs in the stuff that we already written, and none of it was spent fixing stuff because it didn't break, because it was reproducible.
But what do you do in case, for example, somebody defines an incorrect script?
A module in the DSL.
Whatever.
It wouldn't get there. They'd run it locally, it wouldn't compile. They wouldn't be able to produce config XML that makes it on the Jenkins. So they wouldn't be able to get a job, firstly.
Still in a case, for example, write step 1 instead of step 10. In this
So like a
case.
syntax, so you're
That's
talking like a
syntactical
valid
version.
syntactical but a configuration issue?
Yep.
I see. So this comes back to the level of responsibility that I'm talking about. Because what you're doing at that point, when you make the line in the sand that says you define this stuff and I look after the platform, is you're saying you're responsible for defining these things, right? So if they make a misdefinition of things, it's no longer your responsibility to maintain it. And that is the only way to scale, because you can't manage all of them. So it shifts the responsibility. I mean, how to trick your developers into doing the work for you, right? Because that's what it is. It's getting them to do. I mean, it sounds facetious, but the whole point is enabling them or empowering them, if you want to use fancy words, to drive their own platform, or to drive their own requirements, or to fix their own requirements, should I say. So that is like the two areas. It's like, I've been talking like 35 minutes now. That's the two areas that I wanted to talk about. Any questions?
Please share the code and I will give you feedback about this abstraction.
Okay, very good.
But the question is, this abstraction we should talk about is
For the DSL or the Docker?
Yeah, DSL in-house development.
Yeah.
But there is some complexity if we have, for example, steps which are depending on so complex definition.
Yeah.
How you
So this was actually, God, people are like on the point tonight, because this was an issue. Like we had the point that where, okay, so you can define the configuration for things, but you can't necessarily define the order in which they're running or any degree of...
for example, sequence of steps,
Yeah.
build steps.
So we worked around this. We had a stepped interface, so it allowed you to define the modules and then define a little bit more in depth the order in which things were running. But I'll tell you what was interesting. We found that for the best part of like a year and a half, that wasn't even necessary. People were able to abstract the logic themselves because I'll say it again, it comes back to like this border between the two responsibilities, right? They understood that this just runs their, for example, ANT, so they put the complexity of their build steps in the ANT build file, that actually has more benefits other than just offloading the responsibility, because then all of the business logic is in source control, as opposed to in the build and in source control.
Yeah, but in this case, they're moving the complexity of doing stuff in their specific, let's say, tool. For example, they're moving the complexity into the ANT.
Yeah, but why is that a problem? Because the complexity has to exist somewhere. And what I'm saying is it's better for it to exist in
when you
complex.
mentioned you have different database, different setups and so on. So they're moving this complexity of different environments,
Yep.
whatever, into that specific ANT script.
As opposed to within the build script.
Yep.
That's what we were saying. So I don't necessarily see that as a disadvantage, because firstly it enables stuff to run locally. If you have a means of providing if you're familiar with ANT, right? If you have a means of providing the environment for you to run those targets, having the bespoke environment definitions in the ANT files allows you to just deploy it to that machine and run it. Right? That's not necessarily a bad thing. The other part is that the complexity has to exist somewhere, right? And having it in one managed place, particularly managed by the people who are responsible for the complexity, or at least for the people who understand it. Because as a developer, or as a centralized DevOps team, I didn't really care what was running on the infrastructure. I cared that I met the requirements for what was running on the infrastructure. But I didn't really care what you were running. And as such, I don't really want to manage your build environment outside of what it is you need to run it. So I see your point, and again, the stepped ordering was an issue. You can, but what we saw was you could either have a module that allowed you to define the steps themselves within the build logic, within the Jenkins Dsl logic, or as we more commonly saw, people would move the logic into their build scripts. Any more questions? Oh.
Yeah, I have a question.
Yeah.
It's IBM's pretty large company.
Yeah.
The cost, point of cost, how much this program cost for you, and did you manage to calculate how much you save by
The metrics on it.
Yeah.
So, what did I do? Like, we don't have, there's no exact figures. So, but I can break it down. I worked there for 3.5 years within IBM Cambridge, which is where this is related to. At that time, we worked on the platform. So it wasn't, despite being a centralized team, we had to support these 9 projects. So we had to support like changes in business requirements that were much more important than just maintaining the platform. So what I'm getting at is we didn't do this 100% of the time. So if we just say it was 50%, right? And there were 4 developers. Well, if you say a team of 7 people took us, well, this is representative of when I left. So we had the 1, 2, 3, 4 or 5 Jenkins machines, Docker registry, 4 Docker hosts, and the infrastructure behind it. The configuration is code stuff, all of the infrastructure and our in-house system. That end-to-end was 3.5 years, yes, of 7 people's time. I don't think that's very expensive, all things considered. But I couldn't give you the figures. I mean, I could figure it out, but I'd have to tell you how much they paid me, and I'm not going to do that. So. What?
But what if you want to scale your host machines where is Docker? Do you have some preparation scripts, or the question is, do you make some mutable changes before deploy your applications to the host environment?
So to scale the app?
Well, for instance, you clean up the Docker, you install Docker from the zero, from scratch, and then just set up all the environment and then deploy.
I'm not getting the question, sorry. So like, if you want to scale up, what are the difficulties?
Did you use DevOps for yourself?
Did we? Yeah, well, I mean, isn't that not representative?
So for example,
Yeah.
if you want,
Like,
if you want to scale your Docker, did you already prepared and made your life easier?
So it depends on which part of Docker you're talking about.
For instance, you want to add a new host.
Yeah.
Do you have some preparation scripts to install Docker?
Oh, yes. Yeah. And there's Jenkins jobs that are defined in the DSL that do the deployment of it.
This is a part of optimization, yeah?
Of what, sorry?
Optimization.
Yes. In the I mean, it could be so much as that there was a centralized definition of the hosts. I don't think there was, but I think it might have been even just ad hoc because we need to scale the host particularly often. But the platform would allow for it, for example. We already had a job that did the deployment of the stuff that was necessary for the hosts. So you could just point it at the machine and it would be ready to be a host. You could conceivably put all of the host URLs and the credentials for those within source control and then pull that file down whenever it's changed and then deploy. We didn't do that, it wasn't necessary just because I think we had 3 hosts or something like that and they were massive and we didn't really have that scaling issue. But yeah, as far as eating your own dog food, right, like the only way we could do this, like all of our jobs were defined in the DSL language, like literally everything. We got to the point where nobody was defining stuff in anything other than our platform, including us, which allowed us to do all kinds of magic because we understood it well enough. And I'm being told that I need to get off the stage. So. Maybe one more?
Are you done or you?
I could talk about this literally forever. One more question?
Yes. DevOps means development plus operations. How DPO was involved into development process?
Can you start again?
How DPO was involved into development process?
So development and operations.
Or you feel like only operations?
This is such a weird question because I get people like in the old job I used to have people say, "You're not DevOps because you just handle the ops," and then. Like, I came here and I explained what I did to people and they went, "You're not DevOps, you just did the dev." So I don't know where I fit in the equation. But, I mean, it doesn't necessarily, in my mind, right? And this is the problem with the contention about the definition of the term, and it's why I asked about it and why I gave my definition. Like, DevOps doesn't necessarily have to mean development being done by developers in order to further functional parts of a product, right? DevOps could be, in my mind, the development of tooling which enables the development of other developers' developers, right? It's this combination between like the ops side of old ops, which was just, I run a bunch of batch scripts on stuff, to producing tooling and monitoring that allows you to manage those bash scripts that spin up your operations. Like, it's not as clear cut as being able to say, I develop code that goes into a final product. It's more, I develop code that allows other people to develop code that goes into the final product. That's how I see it. But we can't talk about that because, one, like the semantics of the word, we'd be here forever, and also my boss would probably fire me if he really knew how I like define DevOps. So.
Thank you.
Nice.
And can you make something like wine chops or
Yeah. Well, what?
yeah, you
Sure. No, you can't. I don't think so.